Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be looking at simplifying radical expressions. Now, radical expressions are basically anything that is under a square root sign, like you could see in the square root of 36. Now, we know that the square root of 36 is 6. That is because when you're talking about square roots, it is the number that multiplies itself to get that number. So, what if instead I had square root of 4 multiplied by square root of 9? Well, square root of 4 is 2. And square root of 9 is 3. 2 times 3 is 6. What can I see from here? Well, I know that the square root of 36 can be turned into two numbers. I can multiply it 4 times 9. So what does this lead to? This leads to a general rule, and the general rule is that whenever you have a multiplication of two terms underneath a square root, we can separate it into square root of a times square root of b. So let's try that here. This would be turning into square root of 4 times square root of 9, which is 2 times 3, which is 6. So that is the first rule. First rule is if I have square root of two numbers multiplying themselves, we can separate the square roots into two separate square roots. The second rule, and again I'm going to preface this with another example. Let's say I had the square root of, let's go with 16 over 4. Well, the square root of 16 over 4 is the square root of 4, which is 2. Or I can look at it this way. I can say the square root of 16 divided by the square root of 4. Am I going to get the same answer? Well, square root of 16 is 4. Square root of 4 is 2. 4 divided by 2 is 2. So these both give us the same answer. So our second rule would be whenever you have the square root of two numbers being divided, the answer will always be the square root of the top divided by the square root of the bottom. Okay? Obviously, whenever we're talking about square roots, we always have to watch out with our restrictions. So remember, a and b have to be greater than or equal to 0. Okay? So let's continue on here. So the next thing we're going to talk about is what is a radicand. So a radicand. Well, whenever we're talking about a square root, so let's say you have the square root of 4. This number is called the radicand. So the number that is underneath the square root expression. Okay? So let's see how we would simplify some things here. So let's try, for example, square root of 75. Now, when we talk about simplifying, you always have to watch and think to yourself, is 75 the smallest number? Or can I go smaller? Well, to answer that, you have to ask yourself, what multiplies together? So for number one, your first step is always to find the factors. That multiply into 75. And these factors should usually be perfect squares. So 75, I know, is the same thing as saying 25 times 3. Now, using our rules from before, we know that we can split these up. We can split it up into the square root of 25 times the square root of 3. So our second rule is use the radical rules to split. Okay? So the square root of 25, I know, is 5. Square root of 3, on the other hand, it's a decimal number, so you don't really want to go into decimals. So we can just leave it as square root of 3. So 3, can I make that any smaller? No. So my final answer would be square root 3 times 5. So let's look at this in another example. Okay, so let's look at another example. Let's say we had 24. Well, square root of 24, I know, is the same thing as saying 6 times 4. Okay? And if I use my rule, 6, 4, square root of 4, I know, is 2. Square root of 6 is 3 times 2, but that's not a perfect square, so this is the smallest I can go. Okay? Now, what would happen if I didn't know how to make this simplified? Well, that is where we come to prime factorization. So let's say we have the number 24. What is the smallest prime number I know? Smallest prime number I know is 2. Can I divide 24 by 2? Yes. 24 divided by 2 is 12. Can I divide 12 by 2? I can. 12 divided by 2 is 6. Can I divide 6 by 2? I can. Which will give me 3. Can I divide 3 by 2? Nope. Can I divide 3 by 3? Yes. But this is it. These are all prime numbers. So I have 3 2's. 3. So prime factorization here would be 2 to the power of 3 times 3. So if I were to do this question again, to square root of 24, I know it's the same thing as saying 2 to the power of 3 times 3. And if I were to split this up, 2 to the power of 3, 2 to the power of 3, so square root of 3. Now, I know, and this is just a refresher, so recall, if I do the square root of a squared, I will always get a. So here I have 3 2's. So I know this is the same thing as saying 2 to the 2 times 2 to the 1. As another reminder, if I have a to the n times a to the m, this is the same thing as saying a to the n plus m. So let's continue this here. So I can split this up even more into square root of 2 to the 2 times 2 to the 1 times 2 to the 3. Well, 2 to the 2, when I take the square root of it, it goes away, leaving me with 2. Square root of 2, square root of 3, I can't do anything with those, so you're better off putting them back under the same square root, which leaves you with 2 to the square root of 6 as my final answer. And that is how you simplify radical expressions, using prime factorization and the radical rules. The next thing we'll tackle when it comes to radical expressions is what happens when we are multiplying them. Now, when you multiply radical expressions, they work the same way like you would any other kind of multiplication. You would then put the multiplication inside, so this would be the same thing as saying square root of 2 times 10, which is the square root of 20. Now, remember, all these questions always want you to simplify. So at this point, I know that square root of 20, using our same steps as before, is the same thing as saying 4 times 5. Which, if we use our steps, should give me a final answer of 2 root 5. Okay? Now, when you multiply expressions, just like if I have, so I want you to recall, if you have something like this, three x times 4x. Well, in this case, the 3 and the 4 multiply each other. And the x multiply each other. Okay? Which would end up giving me 12x squared. Now, moving forward in time, we're going to deal with this question. And in this question, we follow the exact same rules. The numbers multiply themselves, and of course, the roots multiply themselves. Okay? So that's going to leave me with 8 root 21. 21 is just 7 times 3. Can't really turn any of those into, well, perfect square factors. Nope. So that is my final answer. Okay. Next thing we're going to do is we're going to learn how to add and subtract radicals. So let's say we gave you 4 root 3 plus 2 root 3 minus root 3. Well, flashback. If I gave you 2x plus 4x minus x, this, to be able to add them, first and foremost, you need to look for your like terms. And remember, the like term has to be the same letter, same exponent, same stuff has to be happening. So here I have an x, here I have the same x, here I also have an x. These are all like terms, which means I could do the same thing as saying this is 2 apples plus 4 apples minus an apple. How many apples do I have left? Well, 2 plus 4, I have 6 apples minus an apple. I should have 5 apples, or 5x. Same thing happens when you add and subtract radicals. Now, for them to be like terms, they have to be have to have, and yes, I know, I just realized I used have twice, the exact same square root, okay, or radicand. So in this case, you can see square root of 3, square root of 3, square root of 3. So these are all like terms. Or I can say it's the same thing as saying 4 apples plus 2 apples minus an apple. Well, 4 plus 2 apples, that's 6 apples, minus an apple, that's 5 apples, or in this case, 5 root 3. On the other hand, if I gave you 2x plus 4x squared, these are not like terms because here you have an x, here you also have an x, but it has a squared. This one does not. So these are not like terms. This would be the same thing as saying 2 apples plus 4 bananas. So if I were to give you this example, 4 root 3 plus 2 root 5. I have a square root of 3 here, but I have a square root of 5 here. So these are not like terms. So I cannot add them. Okay? So let's look at our final thing coming up. Okay, so before looking at multiplying binomial radicals, I just want to show you another example here on the left here. So obviously here you kind of ask yourself, you'd say, well, 27 and 48 are not the same, so I can't do anything, right, sir? Well, not exactly true. First, you always want to try to simplify the radical first. Okay, so if I were to simplify the radical, I would have 5. I know 27 is the same thing as saying 9 times 3. And I know 48, well, if you don't know what the perfect square equivalent of 48 is right away, you can simply do prime factorization. So if I do prime factorization, so let's do this here in the corner. So 2, I can divide that, 24, 2, 12, 2, 6, 2, 3. So, how many 2's do I have here? 1, 2, 3, 4. So it's 2 to the power of 4 times 3. So I'll have 2 to the power of 4 times 3. Is equal to 5 square root of 9 times square root of 3 plus 4 square root of 2 to the 4 times square root of 3 is equal to, well, square root of 9 is 3, and square root of 2 to the power of 4 is 2 to the 2. Okay, so let's expand this. 5 times 3 is 15. 2 to 2 is 4, so 4 times 4 is 16, root 3. Uh-oh, look at this. Now, they are both square roots of 3. Which means I can now actually add them together. Okay, so 15 plus 16, that's going to give you 31, root 3. So with that in mind, how would we then do the multiplication? Well, the multiplication, it's the same kind of distribution we do before. So it's, sorry guys, the Pokemon Go example is going to come back here, but square root of 3 would have to multiply with square root of 6 and with 1. So, got to catch them all, guys. So it's going to be square root of 3 times 6 minus square root of 3, which is going to give me square root of 18 minus 3. Once again, these are not the same numbers. So you want to simplify. So that's going to give you square root of 9 times 2 minus square root of 3, which is equal to square root of 9 times square root of 2 minus square root of 3, which is equal to 3 root 2 minus root 3. Can I do anything here? I cannot, because they are now 100% simplified, and they are not like terms. Okay? Alright, so almost done here. Let's continue on. Last one. Okay, let's finish off with a bang here. So, let's say you have 2 root 3 minus 1. 3 root 3 plus 2. Well, just like before, Pokemon Go, you need to distribute. So this has to multiply this, and this, this, and this. You are still doing FOIL. So, we're going to use all of our rules together here. So, 2 root 3 times 3 root 3. Well, the 2 and the 3 will multiply, giving you 6. The root 3's will multiply, giving you square root of 9. A little trick, though, is that whenever you have square root of a times square root of a, the answer is always going to be a. So, in this example, I have square root of 3 times square root of 3. So, my answer should be, my answer should be 3. Okay? Now, if you're not seeing why it's that, it's because of this. Square root of a times square root of a, it's the same thing as saying a squared. And a squared, when you take the square root, it's going to be a. If I do square root of 3 times square root of 3, it's going to be square root of 9. Square root of 9 is 3. Plus 2 root 3 times 2, well, there's no root here, but there is a number. So the numbers will multiply, giving me 4 root 3. So that's done. Minus 1 times 3, minus 3, root 3, minus 2, okay? Then you want to collect your like terms. Oh, simplify this first, so you're going to get 18 plus root 3, so you have these ones, minus 2, which is going to give you 16 plus root 3. Okay? And that is all the radical rules and how to simplify. In the next video, we're going to be looking at how to do division questions. Okay? I hope this video has helped, and sorry for the longness, and have a good day.